So today we're going to be looking at vector subtraction. Vector subtraction. Now, you will remember, yeah, we did it on our handout. Right? Now, you may remember from grade 11 that vector subtraction was, shall we say, challenging. Remember vector subtraction? Yes. Yes. So I'm going to, as I did with vector addition, I'm going to simplify things considerably for you. Considerably. Okay? So, just follow along with me here. So, vector subtraction. We know that the resultant, if we talk about plane and wind, let's use the plane and the wind as our example, our sort of discussion reference. We know that the resultant vector is equal to the plane vector plus the wind vector, and the plus sign simply indicates what? What does the plus sign sort of indicate? It means tip to tail, right? The plus sign indicates that we're going to put them tip to tail, and then we would add by components. Okay, so if we have to, oh, what just happened there? Why is it going smaller on? So if we rearrange to get the plane, if you happen to want to know what the plane speed is, to do this I have to take the wind to the other side, and it turns into a subtraction, resultant minus wind, or if I'm having to solve for the wind speed, well, that's going to be resultant minus plane speed, right? And when we did it in grade 11, we had to, remember when we add, or sorry, when we subtract vectors, we simply add the opposite, right? And you had to take that vector and you had to point in the other direction and you add it. And it really wasn't that hard. The hard part was figuring out when to do it, really. Now that you're older and wiser, I think it's going to be relatively easy, okay? Now, I will tell you that the negative sign, if you want to think about it graphically, simply means place things tail to tail. Okay, now that's not the best idea to think about. I'm just going to put that in there for you in case you sort of run into that in your future physics careers. Okay, but probably the easiest thing to do is to think about it the way we thought about it last year. Okay, suppose you have to subtract two vectors, v2 minus v1. Well, that's exactly equal to v2 plus minus v1, not vi. Right? Just the way we talked about it last year, we're going to add the opposite. Add the opposite, which meant flipping the direction in grade 11, right? Okay, but with components, things are a whole lot simpler. I'm going to go to a new page. Let's do an example here. We're going to do the first one. This is a handout with extra vector questions on it. The hardest part is determining if it is a subtraction. It's easy for this one because I've labeled them subtraction, okay? So let's look at the first one. Lisa is flying an ultralight aircraft with a maximum speed of 15 kilometers an hour. She sets her course at a bearing of north 15 west. So in other words, the plane vector is 15 kilometers per hour, and she's going at north 15 west. That's her plane speed. If there was no wind, that's where she would go. She flies for an hour at the maximum speed and ends up 8 kilometers at a bearing of north 8 west from her start point. She flew for an hour and she ended up 8 kilometers away. So in other words, what is the resultant?
Wait, it's staying in the air at 15 kilometers per hour?
She's flying, the plane's speed, if there was no wind, would register as 15 kilometers an hour. But she only ends up going 8 kilometers and at a bearing of north 8 west because of the wind, right? So what's the overall result? 8 kilometers an hour at north 8 west. So the first part is what was her resultant velocity, which is pretty easy.
Yeah.
Okay. I mean, if it was 2 hours, you would have to divide by 2, right? You guys get that? 8 kilometers, 2 hours, be 4 kilometers an hour. It asks for the wind's velocity, okay? So knowing that the resultant is the plane plus the wind, right? We are solving for the wind is resultant minus plane. So I've got to take this vector and subtract that one, right? It's going to be r minus p, right? R minus p. So let's do the r first. 8 kilometers an hour at north, 8 west. So that's going to be like this. This is an 8. This is rx. This is ry. And this is a, oh, they're both 8. Nice one. So rx is opposite. So that's the sine. So it's going to be 8 sine 8. 8 sine 8. 1.11. Now that's to the left, isn't it? Right? It's to the left, so that's going to be negative. Ry is going to be 8 cos 8. Because it's to the left. Yeah, but the actual vector is 8 kilometers an hour at north, 8 west, right? So it's actually up and to the left, right? So ry is going to be 8 cos 8, which is 7.9, and it's up, so that's positive. Now we do the plane speed. The plane is 15 at north, 15 west. So that's this way. It's a little bit longer and a little bit more of an angle. Left and up again. What was it? 15? Is it 15, 15? It is. 15, 15. This is plane X. This is plane Y. Plane X is going to be 15 sine 15. Minus 3.9. Plane Y is 15 cos 15. .5, I guess, if I round it properly. Okay, so I've got my components, but because I know it's vector subtraction, I have to subtract those. So my wind X is going to be minus 1.11 subtract minus 3.9. So be very careful with subtraction there. It's very, I think it's important to show that so that you don't get messed up, right? $2.79, right? And we'll draw a picture after to sort of confirm it. Wind Y is going to be 7.9 minus 14.5. Minus 6.6. And now you got to do the Pythagoras part, Quinn, right? To put them back together. It's like Humpty Dumpty. Yeah. So 2.79 is my X. My Y is, oh, is minus, so I can put it up here. So that. My wind is down like this at 6.6. That's my wind. So W squared is going to be 2.79 squared plus 6.6 squared. Do I need to worry about the negative in there?
No.
Nope. .17 kilometers per hour, and the wind has to have an angle. So that's going to be 6.6 all over 2.79. 6 divided by 2.79. Take the inverse tan of that. And you get 67 degrees. And that's going to be east, 67 south. Okay, so if you stop and you think, the plane's going like this at 15. The wind is pushing it back kind of like this, right? Which means the overall resultant is like that, which is what it originally was, right? Is it?
So long.
No.
This is awesome. Hard.
It's long, but the steps are going to be always the same. What are the steps, Mary? Determine that it's subtraction, right? How do we know that? Because if we're solving for wind or plane, or boat or current, you're not finding the result, you're finding one of the parts of the overall question.
Always be with your plane or-
Most of the time, yeah. Find the components, do the subtraction, put them back together with Pythagoras, do the angle. That's all there is to it.
We also missed like the last part of the Friday.
Oh.
That's the worst of it.
That was number one.
Can we do Stefan's question?
Can we do Stefan's question?
No, we want to do Stefan's question. A grass is going to grow straight up, but a grasshopper is sitting on a bend
I think Stefan should write that question up, and then we'll do it.
and put it on YouTube to say, I learned.
Okay, if you want to do more vector addition questions, there's some there. There's some vector subtraction. The QR code is there for your enjoyment.
Is he going to float on me again?
I don't
I'm
know.
going to respect
There are also a few questions.
Stefan's.
Page 116, numbers, did we? 37, 38, 39, and 40. What was that beep?
I scanned the shit.
Oh, okay.
I did 37, 38 today.
Good for you. Okay, so that's where we're at. Test is Thursday. Tomorrow, I think what I will do is I will give you what are the kind of questions we can expect to see on the test kind of thing.
The really long ones that everyone hates.
Maybe you guys can cheat sheets, absolutely. Half page.
What happens?